Hello, folks, and welcome to Answer Everywhere. We're looking at source code, as we always do. We're looking at source code we've never seen before, a sight reading. We're doing jazz improv. And we're looking at OpenBao, which you probably have not heard of. Maybe you have heard of it. But it's a fork of Hashicorp Vault, the popular secrets manager. And Hashicorp went like source available with their licenses. And so a bunch of their stuff has been forked as open source. And we're going to look at the code. It's mostly Go and whatever MDX is. But I'll say at the start that I usually don't have much of an opinion going into to most code bases. My impression of the Hashicorp stuff from last I evaluated it was I'm not into it. It's much more stateful than I like. They've got their own configuration language that I don't love. Terraform will like delete your stuff. If you make a mistake, it'll just like delete user data with, I think they've probably done some stuff to improve that slightly in the last however many years, like 4 years or so since I like evaluated it for use. And I've played around with OpenBao the past couple of days, and it seems like they've got some of the similar problems. Like I was looking at the Helm chart, and the Helm chart is doing things like the init script has a bunch of bash to like copy files and like substitute variables for templates and all of this stuff. And it's just very mutate driven. And you personally, for something like this, I kind of wanted it to be stateless and declarative and not have so much kind of like scripting be in the heart of it. However, it does seem like this is the main game in town for storing like self-hosting secrets. I know that there are others that people have may chime in with. If you have one that you particularly love, you are welcome to chime in with it. But this seems to be the big dog, I guess, big dog, whatever you want to call it. So we're gonna peep at it. We're gonna peep. And I guess I don't even know what I want to know most about it. Probably. So my understanding of the architecture is there's an HTTP layer. There's some storage layer. The storage is untrusted. I don't know if you can like use Postgres or some other like MySQL or MariaDB or whatever as your database. I don't know what they're using on the database layer, but the storage is untrusted. There's like a root key, and I think every piece of data, every secret gets its own encryption key that's rotatable. And by the way, this is just off the top of my head. We can verify some of these statements, so don't take this as gospel. But I think every time you add a secret, like, I'm going to add my database, the master database password or something to MariaDB or whatever you use. And that's going to be encrypted with a key specific to that MariaDB password. And then that is like a key encryption key. And that key is encrypted with another key so that when it hits disk, it's not plain text. And that key, I forget what they call it, but that's essentially like a master key. And when you start up an OpenBao or Vault instance, you have to decrypt the master key, which by default they use shamir secret sharing with like 3 of 5 shares to decrypt that. And then that's how like the database layer works. And then there's authentication and authorization and audit logging. And that's, I think, really about it. There's not much else that you need to do with a secret manager. Let's see if we can find the architecture. Do I want the LinkedIn one? Corporate network. This is too blurry. There's some load balancer. This is showing like the server standby versus server active for doing decryption. I think maybe something like this. So there's an HTTP API, some storage backend, audit devices. I guess audit devices are probably like different places to log stuff. I don't know much about auditing. I don't know much about, I think often some of that is for regulation. You are regulated and you have to audit things and then have to be in a certain format or whatever. Some policy store, I'm assuming this is like authorization policy, who can use which keys. Expiration is just going to check whether your keys or like some lease on the key has expired. I don't know what rollback is, or rollback manager is. I don't know if that's for rolling back the keys or something else. And then a place to store the tokens. I assume these are for like the JWT tokens, the JOT tokens, or something along those lines. And then routing. And we can route to the system backend, the secret engine, or the auth method. So I think when you come in first, you go to auth. Maybe you get a token. Maybe it hops in the token cache, which is maybe like some version of Redis or something. And then I don't know what system backend is. It seems to be distinct from the secret engine or the system or the auth method. And then there's some storage backend here, which is untrusted. And the barrier, I think, is what they're referring to as the barrier. I think is essentially the trusted computing base. So with this in mind, we will peek at the code. I'll pull this aside just in case we need to refer to it later. So what should we peep at first? Not audit, not API. Change log, no. Command, probably no. Internal shared, maybe. Physical, scripts, SDK, Terraform, tools, UI, and Vault. I guess let's start with Vault. So Vault has a cluster. Diagnose, which is presumably some form of debugging. External tests. I'm guessing these are just tests that reach some external layer. Quotas, seal, tokens, and a bunch of files here that look promising. We also have raft, and raft is going to be the consensus algorithm. Rekey, I assume, is for rekeying, changing the key, kind of like rotating, maybe the same as rotating. Wrapping is presumably key wrapping. Some UI tests and request handling, list filtering. Request handling. Maybe request handling is good. Maybe forwarding is good. Request forwarding. And the policy store. I think I want policy. Maybe I want policy store. Namespacing, I'm not really sure what that is. I think that's essentially just like a text prefix to the key name. Something about MFA off, presumably multi-factor authorization, login, logical system, logical raw, logical system. I don't know what those are. Those might be cool. Those might not be cool. Init should be maybe for initializing the cluster. Inspectable. And a keyring. Keyring seems pretty fundamental. Generate root. I'm guessing that's the root key. Dynamic system view. I wonder what that is. I guess we'll peek at it. There's a deadlock test, which is good. They should hopefully prove that there is no deadlock with formal methods, but who knows if they do. Cores I'll ignore. Core.go I will look at. We may have opened cluster.go, but at any rate, we will look at it. Capabilities, that might be capability-based security. Barrier is something about the security barrier. I assume auth. And did we look at ACLs? Let's look at those. And then we have seals and tokens and cluster and diagnose. Seal should have the implementation of shamir secret sharing. Okay, so that's Vault. What else do we care about? I think that's about it. Maybe physical. I'm kind of curious what the deal is. We have Postgres, raft, and cross test. So what is raft going to do? I think I opened physical in its own tab, or at least a separate tab. Internal shared. Hashicorp internal libs. Do not use these unless you know what you are doing. I will not then. So PostgreSQL, I'm going to guess, is using Postgres as a backend. Postgres testing transaction, and then raft. Can you store stuff in raft? I mean, you can store a small amount of stuff typically in these, you know, like Zookeeper and whatnot. FSM, it's the something, Bolt Linux. I don't know what that is. So maybe Bolt is an algorithm. Stream layer. I'll just open some of these for raft. Who knows whether they might be interesting or cool or instructive. All right, so that leaves us with a lot of stuff. I'll start with I will start with raft.go, and this is raft in Vault, not raft in the like physical layer raft folder. And how big are we? Over 1,000 lines of code, and we are Golang. And let's find out what MDX is. Is it like the no? It's similar to SQL, but is designed specifically for handling complex data structures with a multi-dimensional format, multi-dimensional expressions. For OLAP cubes, I don't know what an OLAP cube is. Something about OLAP. We've got products and cities and time. Cities? Yeah. Is a multi-dimensional array of data. Online analytical processing is a computer-based technique for analyzing data to look for insights. The term cube here refers to the multi-dimensional dataset, which is sometimes called a hypercube, if the number of dimensions is greater than 3. It is a multi-dimensional generalization of a 2- or 3-dimensional spreadsheet. Okay. Is it though? The spreadsheet has like functionality. Okay. All right. So that's what MDX is. And I guess they're using it. For what? I'm not quite sure. I haven't seen it so far. But here we have raft and get raft index is locked, et cetera, et cetera. Are they implementing their own raft or are they importing some other raft library? You've got discover, clean HTTP, map, structure, whatever that is. Go KMS wrapping from OpenBao. That's just another of their things. They're importing some stuff from Hashicorp like hclog, hclog, something about HCL, OG, and UUIDs. So this seems to be maybe their own implementation of Raft. Start Raft backend will call setup cluster in the Raft backend, which starts Raft up and enables the cluster handler. So let's look at start Raft backend. We're going to get the backend from the context, and if it's nil, we will return nil. And there's a bool called creating, and I'm guessing it's going to be telling us whether we are in the process of creating it. And we're going to get a key ring from the Raft. It has some TLS key ring. And if it's not initialized, then retrieve the Raft TLS information. We're going to look at the barrier and get the TLS storage path and do some error handling. And then that gives us a TLS entry. And if it's nil, we'll do one thing. If it, what? This is some switch statement. Switch nil. Oh, yeah, switch. Is it the only case? Where are the other cases? Is this a pattern? I don't know. Oh, default case. Yeah, that's kind of weird. Maybe that's a Go thing. We'll take the keyring, call new on it, and get a raft TLS and check for errors. And we're going to check it to see if it has state, and if not, blah, 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 blah. And then we've got a func, and then we're going to defer. That's what? To tear down the cluster if there's an error. Okay. So that's something about starting it up. What did we actually do? We tore it down if it failed. Oh, we called raft backend setup cluster with the setup options, giving it the key ring and some cluster listener. And start as leader is set to creating. So where is creating populated? Creating is true if raft TLS entry is nil. I guess that means that like nobody else is trying to create the cluster or something. Rock on. What else do we want to see here? I don't really know. Rotate phased. Let's take a look at the join rafts and answer. Okay, whatever. Is raft unseal? We're going to look at the raft info.load and the raft information and check if it's nil. And I guess if it is unsealed, it will be non-nil is the idea. Okay, that's enough raft.go for me for Vault. Here's a rekey. I don't know if this is the most coolest thing, but let's figure out at least what it is. We have a rekey result. It's used to provide the key parts back after they are generated as part of the rekey. So we've got secret shares, which is a list of byte lists, a list of strings essentially. We've got some PGP fingerprints. So I guess we're using some like fingerprinting algorithm from PGP. And some verify result, whether it's complete and a nonce for the new key, I assume. And we have a rekey threshold. It returns the secret threshold for the current seal config. This threshold can either be the barrier key threshold or the recovery key threshold, depending on whether rekey is being performed on the recovery key or whether the seal supports recovery keys. Okay, so I'm guessing this really is for rekeying, but to rekey, I guess the master key or whatever it's called, you have to unseal it or something. And I guess that's what it means. I think that this is not the main unsealing implementation, but let's move on. Here is seal.go. We've got an AEAD wrapper, which is some OpenBao thing for AEAD encryption thingamajiggies, and a wrapper for them. We've got protobufs. Are we storing keys in protobufs? We've got a reference to the physical later, some JSON util, and so on. Const. So there's a path used for our seal configuration, which is core/seal config. There's a recovery config path, and so on. Some paths, and they're all under core. The seal interface, you can set the core. You can init, finalize, stored key supported. Okay. Seal wrappable, set stored keys, get stored keys, barriers type, etc. Recovery config, verify recovery key, get access. So let's see where they actually do the unseal. Set barrier config. Here's a seal config struct. Hello. Afham. Might want to read this Reddit to get people's views on OpenBao. Which Reddit? There's only one Reddit that I know of. Okay, so base validate. Base validate is used as a shared base between validate and validate recovery. Okay, so if secret shares is bigger than 1, we're going to return an error. Threshold must be greater than 1 for multiple shares. This seems like maybe this is run during the configuration. So you can't have more than 255 shares, and so on. And if stored shares is bigger than 1, stored keys cannot be larger than 1. I don't know what a stored share is. Maybe you can store a secret share. I don't know why you would want to. And then we've got PGP keys. Account mismatch between the number of provided PGP keys and number of shares. And then we have a validate function that just checks if the secret shares is less than 1 or the secret threshold is less than 1, and then otherwise which calls base validate. But didn't this also check if secret shares is... Oh, this is if it's bigger one. Wait, what? Oh, this is if it's between 1 and 2. Okay. Huh. It's not letting you, I haven't set it up in any particular way, but it's not letting you send links. I don't know why. I can look up OpenBao Reddit. Is it this one? OpenBao versus Hashicorp Vault. Let me know if it's one of these. Then we have a seal config. Oh, no, we have clone. We already saw the seal config. We can clone, and it's just going to clone. We don't need to look at that. I see some protobuf marshalling. Or maybe it's JSON marshalling. So it's going to encode the seal configuration. So we've got some config. It's JSON. We're going to put it somewhere. I think the fourth one. Okay. Maybe this one. This is 2 years ago. What are the reals? Yeah. Atrocious open source branding. This is just people moaning. I don't really care about that. But I mean, people are allowed to have whatever opinion they want. But I'm not into the just complaining. Okay, so seal config. I want to see unseal. This is about all the config stuff. Byte, barrier, unmarshal. So let's see. So maybe this is just seal. Maybe it's not unseal. Is raft unseal? Okay, I think that's not gonna give us the implementation of unseal, but what we can do is we can try to find the unseal function. No. What if we look for shamir? Okay. This, but compared to OpenVault involved my job, there's not much difference. Yeah. Look at the basic Vault Enterprises features like namespaces, disaster recovery, etc. So I think that's probably right. So Vault has like enterprise features. I'm assuming that OpenBao is going to implement some of them as open source. We used Vault, but recently switched to OpenBao, so we haven't missed haven't missed anything. People promoting infiscal and physical. It's everything but open source. It's open core. Vault is available today. OpenBao is more or less will be in the future. This is 4 months ago. Yeah, well, seems like people mostly like it. I'm not sure if it's production, but that I mean, they've literally taken the code. There are still Vault references to it. So I don't think they've done a lot of work yet. Here's the shamir flow. This is in UI though. Shamir progress in the UI. Vault seal.go, get shamir wrapper. And lots of UI code. And rotate with a shamir helper. So let's look at the shamir wrapper part. So get shamir wrapper we've got this AEAD wrapper that has a shamir wrapper like reference to it. Default seal is meant to be for shamir seals. So it should always have a shamir wrapper. Nonetheless, new default seal does not check, so let's play it safe. Okay. So, I don't know. Maybe we can look up shamir wrapper. There's auto unseal, wiki, ha.go, init.go, rotate server.go. Seal testing. Let's look at seal testing. That'll tell us at least, how it works. New default seal, new blah, blah, blah. Stored key not supported. Stored key supported shamir root. New default seal, and this is some config. Stored shares is 1, select threshold is 1, secret shares is 1. And then we're going to call new test seal. New auto seal. That's just returning the thing. I don't know. I don't know where it's actually called. How about where's the operator? Here's the operator. At least the operator command. Let's look at Let's see if we can figure out where this actually calls. I'm not sure. We can check the API. It's probably, the entry point is probably in the API. Auth, go, KV, request, sys monitor, sys seal, seal status with context, seal with context, unseal with context. Okay. What? So unseal with context is going to take a context. And we're going to get something. We're going to create a map from keys to shards. It's called a body. And then, whoa. We're going to call CC new request. And I'm guessing that what this is doing is waiting for a new request to the unseal endpoint. And that's going to give you some request. Then we're going to call R, set JSON body to body. Check that errors are non-nil. And then we're going to call seal status request with context. No, do that. I'm going to do that. And then seal status request with context is going to take the context, the reference to the sys, and the request, and it's going to return the seal status response. So we've given it a request, and this is the thing that's going to generate a response, which is presumably going to tell you whether you have more unsealing to do. So the way that it works is when you ask it to unseal with the secret shares, you call the unseal endpoint 3 times in a row with different secret shares. Yep, I personally used oh, okay. So you've used OpenBao before? I'm curious to hear your have you been on the DevOps side? I'm curious to hear if that's what that is like. I haven't really used Vault. I don't think I've used either of them. Okay, so we get with configured timeout some context. So there's some, I guess, this is probably just handling timeout situation. And then we're going to defer the cancel function. This is, I guess, looking up the timeout, which returns the function to run on cancellation, I guess. And then we've got raw request with context. That looks like similar to what we just saw. But maybe this is just what did we see? Maybe we saw like unseal with context, and this is raw request with context. And that's going to get us a response. And we're going to check to make sure it's not nil. And we're going to defer closing the body. And then we're going to create a seal status response, which is empty. And then we're going to call decode JSON, passing in the empty thingy and returning it. So where did the work get done? Here? Resp. Yeah, I see. No, I don't see. So resp is some JSON response. And here, I guess we're decoding it. So this must be where the work gets done. I don't see where we've like computed that we have more responses to go or more shares to look at or whatnot. Here's client echo, raw request with response. I don't know. This has a bunch of stuff, including back off, maximum retries, just the kind of standard client stuff. This is the client, right? Raw request with context on the client. And limiters and redirects, whatever start is. Output curl string, output policy, back off. This is like kind of HTTP level related. It doesn't seem to be have any behavior. So I don't know. I don't really know. I don't feel like I really understand at all where this work is being done. Okay, let's ask Gemini. Where is the code that runs on Unseal and checks whether you have enough Shamir secret shares to unseal the cluster, the node? I think you unseal at the node level. And while I was thinking of that, we'll move along. Okay, so let's ignore seal. Let's look at UI. What is UI? It's going to be the web interface. This has what? Some stuff like service worker allowed, X content type options, no sniff. That's header stuff. Here's more header stuff. Set header, get header, delete header. It's kind of weird that they're implementing their own libraries at this level. Maybe that's because it's security focused. Maybe they don't want to depend on other libraries. But that seems a little bit... let me back that up. When I say maybe that's because it's security focused, that's a separate thought from maybe they don't want to depend on other libraries. I think typically you would want to depend on other libraries that are well established. If you are security focused, you would not want to roll your own. What I mean is that maybe there are, because this is a secret sharing thing, that maybe there are additional considerations on top of the basic libraries that they need to care about. But so far it looks like pretty much just ordinary HTTP stuff with locking. And that's a little bit strange. We do have this physical storage stuff. So if you call save, it gets a context and a UI config entry. And if the length of the config headers is 0, and then we're going to call the physical storage and try to delete the UI config plain text entry, plain text key, and return error. So I guess in the UI, you paste in a key, and I think that probably is what the plain text key is. Although, who knows? And I think the config in general, config and policy is also stored encrypted like a secret in Vault, but I'm not sure really what that particular code is doing. Wrapping, I'm going to guess is key wrapping. Ensure wrapping key. We're going to call the barrier and get the core wrapping jot key path. Core wrapping jot key. Why jot? I don't know. But this is something. We haven't looked at barrier yet, but that's going to be interesting code. Why don't we look at that next? We've got cluster key params. And the jot key path thing gave us an entry. And if that entry is nil, we will do error handling, I guess. Or no, we'll generate it. We're going to generate an ECDSA key. So elliptic curve DSA on the P521 curve with a secure random reader. I'm guessing this is mainly a secure version of an RNG. And then setting the different parameters. So we have the DX and Y. And the key type is core private key type P521. That's going to be the wrapping key. So this is asymmetric crypto. So where's the corresponding public key? Or is ECDSA an elliptic curve symmetric? I forget that. Let's take a look at that. And then we're going to call barrier put, etc. So barrier has like a put method. Where are we putting it to? I don't know. The storage entry. This is like some essentially going to create some JSON, I think, with the wrapping key. With the wrapping key path and the value. So we're storing the key material. The request is the key material and where it's going to go, and then we're going to call put on that. And this is presumably going to know where to stuff that. So let's look up ECDSA, and then we'll check back with Gemini. Oh, it's signature. That makes sense. Wait a minute. So why is the wrapping key? Wait a minute. Why is the wrapping key signature key? Is that right? Let's ask about that. Okay. What do you got for me? It's certainly not succinct. So it says the classic shamir secret sharing key. All right. Okay, so I'll find that code for you. I'll start by searching for shamir in the code base. I already did that. It's a lot of noise. It seems that shamir is a popular term in this project. It's almost as if they're proud of using it. Yeah, that's a good point. Okay, so did it actually find anything? I've been graced with a wall of text. How illuminating. The key functions involved in the unsealing process. The main logic is in Vault core Go. The process starts with the unseal function, which calls unseal fragment. There you go. This in turn calls record unsealed part to store the key share you provide. The crucial part is the get unseal key function. This is where the system checks if it has enough keys. It compares the number of keys you provided with the required threshold, etc. Okay. Tell me about the use of ECDSA and where is it suggested to use and where is it not? Don't look at the code. Just tell me what you know. All right, so let's try that. Sometimes something like that can prompt it to just load into context what it knows as like best practices and stuff. All right, so let's look at core.go. I have it opened up somewhere, but I'm not going to search for it. Here's core.go. Hello, GitHub. Okay, so if we believe it, there's some unseal stuff here. What is it, fragment? Okay, okay, so we do have the unseal fragment. No. I can jump to it in Emacs. Can I jump to it here? Yes. Unseal fragment, okay, great. Unseal takes a key fragment and attempts to use it to unseal Vault. Vault may remain sealed afterwards, even when there is no error returned. Okay, depending on whether enough key fragments were provided to meet the target threshold. The provided key should be a recovery key fragment if the seal is an auto unseal, etc., etc. Okay, so what is it going to do? So unseal fragment is going to take a byte, a key byte, which is a little bit unusual because you do get the keys in byte form at first, and maybe this is the only way to do it. So you will get essentially a string from the user, which is going to encode bytes, but you're going to decode into bytes. I had thought that security best practice was to immediately get out of bytes as quickly as possible and put it into a key, some like key structure. However, we don't have a key, we have a fragment. So they'd have to have a fragment structure. And I guess they're just not doing that. They're just YOLOing with the bytes. Here we do metrics. We're going to call some state lock and lock it, which I'm not really sure what there is to lock since we're not unsealed yet. And then we're going to defer the unlock. I don't know enough about Go, but that seems a bit imprecise. It just says like unlock later. So how are you going to prevent that from deadlocking? Let me ask something. Let me ask I don't know, DeepSeek. All right, so take a look at the start of this Go function. Is deferring unlock standard Go idiom. Let's see what you think, Mr. Deep Think. Should I tell it to Deep Think? Yeah, why not? It's gonna take longer. All right, back to this code. All right. If migrate, we'll do some stuff. Let's pretend we're not migrating. We're gonna init something. Call C initialized on the context. Explicitly check for init status. This also checks if the seal configuration is valid. So before you unseal, you have to init. And initting is the thing that like prints out the secret shares for you, and also the initial root token. And you're going to store them. You're going to split those shares up among your friends. They're going to put them in safety deposit boxes. Those safety deposit boxes will go in a secure, a gigantic safe. And then you're going to hire thugs to protect them around the clock and put them in different countries. And then your shares are safe, but you can't restart your pods. And so to get the actual shares, you need to initialize. And I think that this is checking to see if that's been done, because you can't unseal if no key material has been generated. And then we're going to look at if it's raft unseal. I'm not sure if raft unseal is good or bad. If not init, so not init is bad, and not raft unseal, then we're going to say error not init. So I'm guessing raft unseal. Oh, I'm guessing raft unseal is maybe like we're going to maybe we unseal one of the nodes, one of the pods in Kubernetes language, and they're going to gossip somehow the key material and unseal each other, or something along those lines. Or maybe that's maybe that's the internal technical term for what they call auto unseal, which is you can like ask like an HSM or cloud KMS or something to unseal you. We're going to verify the key length by checking at the barrier, get the key length. And then that's going to give us a min and a max. And the max, we're going to add the shamir share overhead. I don't really know how shamir secret sharing works. Maybe they create a longer buffer. And we're going to check the key. And if it's not if it's shorter than a valid share should be, then you say there's an error. If it's bigger than a max, then you say it's longer than maximum. I'm guessing share overhead is maybe what I said was wrong. I think now the share overhead is probably just the metadata. However they store the key, which is maybe some like serialized proto or something, just some metadata, I think, for doing the sharing. And if the context is sealed, the context is like this global information that's like passed into all of the functions. If the context is sealed, we'll return nil. Sorry, if we're not sealed, we will return nil. And I guess the UI will know that nil means that you are already unsealed or something. And then the seal to use we'll get by calling the context to seal. And if we are migrating, we'll do something, but we'll ignore that. And then we're going to record the unseal part, passing in the key. That's going to give us a new key. I don't know what record means. Maybe we're stashing it somewhere. Probably not to disk. And if we have no key, that's an error. Then we're going to call get unseal key on the context and the seal to use. That's going to give us a combined key. I guess record unseal part is stashing it somewhere. Otherwise, get unseal key, I think, couldn't do what it needs to do. But where is it stashing it? I assume in memory, maybe in some like hash table or something, or just some list. And then that gives us a combined key. And maybe that combined key is enough, and maybe it's not. So if there's no error, if there is an error, or the combined key is nil, we return error. If we're migrating, we don't care, we're ignoring it. If it's raft unseal, we'll call unseal with raft on the combined key. If the unseal key to root key pre-unseal gives us a root key, we'll call seal internal. What? So all of that makes sense, except now I don't know I don't understand the code path for if you gave it a valid key share, but you're not quite done. That's the code path I don't understand. And is it something I skipped, or is it just one of these functions is handling that. Okay, seal to use, migrate, blah, blah, record unseal part if there's no new key. Get unseal key returns either a recovery key, in the case of auto unseal, or an unseal key, a new style shamir. But is it necessarily the final key? I don't understand this. I'm guessing it's not necessarily the final key. We'll look at unseal internal. Although it is saying root key. Or maybe it's just an error condition. Maybe not being finished is considered an error or something. Invalid key, key is shorter. Record unseal part. So this is, I believe, calling it the root key suggests to me that they think they're done. So let's look at what get unseal key is. Get unseal key uses key fragments recorded by record unseal part and returns the combined key if the key share threshold is met. If the key fragments are part of a recovery key, also verify that it matches the stored recovery key on disk. Okay, so what if we don't have enough shares? Check if we have enough keys to unlock. Proceed through the rest of the call only if we've met that threshold. Okay, so if the number of unlock info parts is less than the secret share threshold, then we might debug log, can't unseal, not enough keys. We're going to return nil nil. Okay, so that means error is nil, but also the key is nil. So that is here. Okay. That is really confusing. Okay, so I think that what's going on is if you don't have enough shares, that is not explicitly called out in the code. It's not really even visible in the code. But what happens is both combined key and error are nil. So error not equals nil fails. And combined key equals nil succeeds. And we OR them together so it succeeds. And we return error, and error is nil. So the end result is that if you don't have enough keys, you return nil. That's super confusing. I personally think they should do just a separate line to say that if there are not enough keys, we return nil, separate from the error check. And we shouldn't return error. We should return nil, maybe with a comment saying that combined keys is nil. Okay, so here's the. I asked it about Golang. Wow, this is a lot of thinking. It demonstrates two standard and idiomatic uses of defer. So metrics, I don't care about that. This guarantees that the mutex is unlocked when the function exits, which is fundamental Go idiom. Okay. It's called even the function has multiple panics, blah, 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 charity. Clarity, not charity. It is, ensure the critical section is short. Okay, so is it not harder to understand deadlocks if you don't know exactly when the unlock happens? I mean, I guess it depends on like how complicated the function is, whether there's like error handling and stuff. Defer your mutex unlocks. Isn't it just better to not panic? Isn't it too much obvious? You should only hold a mutex for as long as it takes to deal with the protected item, and ideally no longer. So if you defer unlocks, make sure your functions are short and not doing anything they don't need to be doing. Okay. But that was a long function, wasn't it? It prevents far more deadlocks than it causes. Okay. So where's the defer? What function did I give it? We'll get back to you. Gemini. defer C state lock unlock. Okay, so what was the function name? Unseal fragment. So it begins on 1489. I think it ends on 1568. So yeah, I mean, maybe it's good practice, but it seems like it's doing a lot of stuff, calling a bunch of functions with error handling and so on. Okay, but that's the way Go is, and I'm not going to question it. So let's ask. So I had asked Gemini, I think, about ECDSA. It's one of the things that tech bros love to throw around that sounds smart. Is it? At its core, it does one thing. It creates a digital signature. When to use it? Resource-constrained environments. Network performance, cryptocurrencies. Okay. When not to use it. Do not use it for encryption. This is the most common and most dangerous mistake. ECDSA is for signatures only. It mathematically cannot be used to encrypt data. If you need to encrypt something with elliptic curves, you need a different algorithm, like ECIES. Conflating the two is a rookie mistake. Don't implement it yourself, and long-term security versus quantum hype. Okay, so tell me about the code that does, what is it? It's not wrapping. So where is it? So look at wrapping.go. And tell me what you think about their wrapping key design. Okay, so that at least now we understand how unsealing works. Are there any of these functions that we want to take a closer look at? Unseal fragment. What did we see? Get unseal key migration is raft unseal. Unseal key to root pre-unseal. We did see a little bit of get unseal key, just enough to see what happened when there were not enough shares. And shamir combine is what I want. So can I find this function? Shamir. Show more. Shamir.go. Is it the SDK helper? Add. Adds combines two numbers in GF 2 to the 8. So this is some field, some mathematical field on 2 to the 8th elements, if I remember what that notation means. Or is it, well, it's not a field if it has, there's a characteristic 2 field. So, and I think this means it has 2 to 8 elements. This can be used for subtraction since it is symmetric. Great. And this is what in Go, split. Split takes an arbitrarily long secret and generates its parts. Number of shares, threshold of which are required to construct the secret. Okay, so you give it a secret again as a list of bytes, which is not great. A threshold int. And we're going to check if the parts is bigger than 25, is less than 25, is bigger than 25, blah, blah. We're going to call shuffle to x coordinates. That's going to give us x coordinates. There's a random list of coordinates. How random? I don't know. Maybe we can look at that in a little bit. Allocate output array. Initialize the final byte of the output array with offset. The representation of blah, blah, blah is this. This is the sort of stuff where if I were implementing crypto, anytime I see a loop, I want to, I don't know like which loops need to be like constant time. I know obviously decryption and encryption need to be constant time, but I don't know enough about side channel attacks to know like which of the stuff you need to really harden. We're going to call make polynomial. etc. And for all of the parts, we're going to get X coordinates and Y coordinates and so on and so forth. Okay, so this is like hand-rolled Shamir secret sharing as opposed to using a library. Is there a library? I don't know. We'll look up Shamir's secret sharing. An efficient secret sharing algorithm for distributed private information among a group. Okay. Here's the mathematical formulation. It is an ideal and perfect Kn threshold scheme based on polynomial interpolation over finite fields. Okay. So I think this is mainly a generalization of the idea that if you have a point, it's defined by one number or one coordinate. If you have a line, it's defined by two coordinates. If you have a what's it called, like a parabola is the name of the geometric shape. But if you have a second degree polynomial, it's defined by its roots, of which there are two over the completion of the real numbers, over the complex numbers. And in general, an n degree polynomial will have n roots. And so I think that what they're doing is if I kind of recall vaguely, that if you want a key that is open with 3 of 5 shares, you get some polynomial and generate 5 points on it, and any 3 of those points will define the same polynomial. And then you do what? You, I guess, get some specific point on that polynomial, or maybe you define the polynomial by breaking up the key material or something like that. So that's my guess. We're going to see what they actually do. Okay, so knowledge of K or more shares of Si makes S computable. That is this. Okay, hang on. You divide a key S, for example, the combination to a safe, into n pieces of data, S1 to Sn known as shares, in such a way that knowledge of any K or more shares, S sub I, makes S computable. That is, the entire secret S can be reconstructed from any combination of K shares. The knowledge of K minus 1 or fewer shares is completely undetermined. So I guess this is the same sense in which if you just have a point on the plane, there's an infinite number of lines that can go through it. If n equals k, then all of the shares are needed to reconstruct the secret S. Assume that a secret S can be represented as an element of a finite field G of Q, where Q is greater than the number n of the shares to be generated. So, so 2 to the 8 is what, 256? Yeah, okay. So that's why the maximum number of shares is 255, because 2 to the 8 gives us a field with 256 elements. So somewhere I saw GFP. If P is a prime number and X is the field GFP. So here they're using GFP where P is the... no, that could be either way. I feel cannot. Okay, so blah, blah, blah. The number of elements of a field is called its order. A field of order Q exists, blah, 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 P to the K. So Q is the order and G of Q is the notation. That's all I wanted to check, just to verify that, just a sanity check that that's what that meant. So we have Q, elements of the field, and that's bigger than the number of shares. We're going to randomly choose K minus 1 elements and construct the polynomial. F of X is equal to all this stuff. Compute any n points out on the curve. For instance, just take the polynomial and evaluate it at 0, 1, 2, 3, or sorry, not 0, but 1 up to n. Every participant is given a point. Given any subset of these pairs, A0 can be obtained by using interpolation, with one possible formula for doing it. And by interpolation, they mean like I was saying before, if you have what do I mean? I get this. This seems like it might be different from the roots, the root idea. Given any subset of these, they can be defined, obtained using interpolation. With one possible formula to being we're going to sum over the y's, and we also have the product of xm over xm minus xj. So we're dividing out by, I don't know what the i's are for m not equal to j. Okay. We'll look at interpolation too. So interpolation I mainly associate with numerical analysis. This is linear. Oh, okay. But we're not doing linear interpolation. I think we're doing polynomial interpolation in the, yeah, okay. So we're just finding like if we have 1, 2, 3 points and they come from a parabola, I guess we interpolate the parabola that goes through the 3 points or whatever is I guess what they're doing. Okay, so all that's straightforward. And, but what is the actual key? Okay, so S was the key. The secret S can be represented as an element A0. Okay, so A0 is the key. It's the constant of the polynomial. And so it's the polynomial evaluated at 0, which is what it says down here. That's why you couldn't substitute 0 to get one of the things. Okay, so this obviously works. Is it the only thing that works? I don't know. But it does. Is there? So it's not a root of this polynomial. I don't know if the root thing works, but F0 it is a root of F0 minus the key is one way to think of it. So if you take the polynomial f of x minus a0, that's some polynomial with no constant part. And F0, A0, the key, f of 0 evaluates to A0, and that's a root. A0 minus itself. Okay. Fine. You know what I'm trying to say. Okay. So back to Gemini. I asked it to look at the wrapping key. Let's take a look. You're asking about the vault wrapping and its wrapping key design. It deals with response wrapping, a feature where instead of getting the secret directly, you get a short-lived single-use token. You then use that token to unwrap the actual secret. Okay, the key in question is specifically for when the wrapping token is formatted as a JOT. Okay, so they got the basics right. The standard crypto, they're using ECDSA with P521 curve and signing with ES512. Okay. They're using Go Jose. So Jose is like is that the standard JOT proposal? I think that's the standard JOT. What's the word standard? Yeah, that's like the JSON Web Token standard. Okay, the not so good, no key rotation. I think they probably do support key rotation somewhere. The artisanal curve choice using P521 is a choice. It's like choosing a weird, obscure craft beer. Okay. Okay, so what is ECDSA used for? In this design, to create a digital signature on the response wrapping JOTs. You ask the vault for a secret, you tell it to wrap the response in a JOT, the vault creates a temporary token. Okay, so it is used for signatures. That's fine. I thought it was being used for the wrapping key. So what kind of did they use for the actual wrapping? And whoa. Let's go here. So I'm going to ask this about the Shamir secret sharing. In Shamir secret sharing, we typically break the Do I still have that open? We encode a polynomial f where f of 0 is our key, and use polynomial interpolation to get back the key from some number of shares. Is that correct? And I didn't mean to send this, but is it also true? So consider a secret sharing setup where we represent, shut up, instead have a polynomial and share. I guess the thing here is that if you're sharing the roots, then those are very specific points of the polynomial. And so this is much more general. 5 points on the polynomial. Yeah, so that doesn't even, never mind. What I'm saying doesn't even work because if you share 5 points, 3 of which are roots, then the other 2 points won't be roots. And that's why we do it this way. Okay, that makes sense. I just want to understand what I was not, why the obvious thing wouldn't work. And it's because you can't share more keys than you have roots of the polynomial, or you could, never mind. Yeah. Okay, that's all good. All right, so that's shamir. We looked at shamir. That's fine. We looked at wrapping. That's fine. Request handling and all that stuff, I don't really care about. And I think we've been going for a long time, so we might just call it a day here, an hour and 16. Is there anything else I really want to see? We have policy type, deny capability, deny read capability, etc. Data version, shallow clone, MFA methods. Okay. I think I'm just going to call it a day here. I don't think there's anything really else that I wanted to see. We got a sense of what they're up to. Init. No, I wanted to see the storage. And I want to see the barrier. Okay, so let's look at barrier and then let's look quickly at storage. I think we'll be ready to go. Okay, the barrier. Air barrier sealed. Barrier already in it. We have some keyring path, some root key, etc. Security barrier core. Initialize checks if the barrier has been initialized and has a root key set. Initialize, generate key, sealed, unseal, etc. So it feels like barrier is maybe just a euphemism for this storage or anything that's encrypted by the storage. I guess it's all the things that are encrypted and need to be unencrypted, I think. Security barrier is a critical component of Vault. It is used to wrap an untrusted physical backend and provide a single point of encryption, decryption, and checksum verification. Okay, so I think that's what they mean by barrier. What I was saying is the encrypt this part, that this is the boundary, but by barrier, they mean this is the single point. There's nowhere else. Like everything is forced through this one pipeline. And that way they can focus on making it nice and secure. A security barrier interface has a security barrier core and some logical storage. It must provide the storage APIs. Okay, and we've got key info, and there's not really anything here. There's the barrier core and the storage, and that's it. And then we have barrier encryptor, which is going to do what? Be the encryptor, but where is decryptor? Destroy, upgrade. So maybe encryptor handles both encryption and decryption. Barrier encryptor has encrypt and decrypt. Okay, great. Barrier access. This maybe is something like ACLI, something with ACLs. Barrier access. We've got encrypt which is going to take a plain text as bytes, a key as a string. I'm going to guess this is like a reference to the key and not the key material itself. And we're going to call barrier encryptor encrypt. And what? It's not really doing anything. It's a wraparound barrier encryptor that allows Core to expose its barrier, encrypt, decrypt operations through barrier encryptor access while restricting the ability to modify the core barrier itself. So it's just an internal versus external boundary. Okay, great. That's all good. And what else? What else? So here's physical raft. I don't know. Here's Postgres. Let's look quickly at Postgres. I'm guessing that once they have the barrier design, storage should be relatively simple because we're just storing encrypted blobs. Some Postgres lock stuff, Postgres lock struct. Okay. It implements a lock using the PostgreSQL client. So maybe they're using row locks. We've got a new backend. We've got some connection URL, et cetera, max parallel, max idle. So I guess like configurations of Postgres. We've got some queries, and we're building up queries by taking variables and plopping them in, which I guess you can do. I thought you, yeah. Okay. And we have connection URL, do retry. Okay, so far this is simple. Here's a create table query. Create table if not exist, HA table, an HA key, an HA identity, and an HA value. So this stuff is not the most testable, but it's also not detestable. Periodically renew lock. Okay, so it's just some Postgres implementation. Raft.go in physical. We looked at one raft.go, and there's a raft store. There's a snap store, snapshot, or a snapshot mechanism. Snapshot is our snap store is our snapshot mechanism. Okay. Raft init channel. Raft is an instance of Raft you'll operate on. FSM is the state store for Vault's data. What is FSM? Finite state machine? HSM? It's different from hardware security module. And this is just the file I'm looking at, fsm.go. This is a hack because raft chunking doesn't play nicely with lower level usages of blah, 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 blah. Okay, so is there a raft store? Did I see that? No, raft storage. I don't know, but it certainly looks like they're trying to store stuff in raft. And except they've got this FSM thing. FSM close, B, FSM is nil, latest state. Get configuration offline is used to read the stale last known raft configuration to this node. Okay, I don't know. Let's see if we have FSM. Here we go. Is there a comment at the top? No. Data bucket. So we have some sort of buckets with data, config, etc. FSM retry. FSM is Vault's primary state storage. It writes updates to a Vault DB file that lives on local disk. FSM implements Raft FSM and physical backend interfaces. So I don't know what FSM stands for, but it says a Vault DB file. Vault DB, an embedded key value. So this is archived by owner. It's now read-only. All right. So this is, I think, maybe similar to RocksDB or all the other key value database stores, LevelDB, BerkeleyDB. It's got some transactions or whatever. So what happened to it? Yeah, so I guess we're still using it, even though it's archived. Bolt storage is the collection of input parameters for setting up Bolt storage, Bolt snapshot. So are they importing cache bolt DB. Oh, maybe it became part of etcd. etcd.io/bbolt is a fork of Ben Johnson's Bolt key value store. So that's Ben Johnson. This is boltdb.bolt/bolt. Okay, an active maintenance and development target for Bolt. Okay, so it seems like Bolt is no longer developed by its main developers. etcd has taken it on. I don't know if that means it's in maintenance mode. Comparison with other databases. Okay, so it's similar to all those other databases, LevelDB, RocksDB, I assume. I still don't know what FSM stands for. Can you store stuff in Raft? Let's see if we can find an answer. Integrated stores, Raft backend. Maybe FSM is like a Hashicorp like code name that has no meaning now in the outside world. Oh, it was just, I guess I should have used ripgrep. Okay, forget about that, but what does FSM stand for in this repo? It has something to do with Raft and the Bolt DB. Yeah, I had forgotten my. Okay, so while Gemini is answering that particular thing, let's try Nano Banana. Draw a bao is just like a dumpling, right? A Chinese dumpling. Draw a bao and a vault and let's try this. All right, so we'll give it a bao. We'll give it, how about like this? I just saw one I wanted. Where was it? This one. We'll add a raft. Do we like any of these? How about this one? Hey now, hey now. Create an image that combines these elements. Make it engaging and wonderful. Okay, we'll come to that, back to that. This is asking about FSM. It stands for the finite state. No way. This doesn't sound right. I don't believe this. Is that right? Raft's primary job is to make sure that every node agrees on the exact same sequence of operations. FSM's job is what actually executes the items. I don't know. Wait, OpenBao. Let's look for finite. And regrep it to get color. And get rid of all definitelys. I don't think that I believe this. Oh, Vault. Yeah, nothing. Physical. I don't think that's real. All right, this is okay. Let's say make it more whimsical. Okay, now all those little chefs on the ground. All right, that's all for me. We didn't see all of OpenBao. We didn't even see really a lot of it, but we did see some of the unsealing. We have a sense now of how it's laid out. A lot of the Golang code is going to map pretty cleanly onto the documentation, which is very robust. One thing I didn't ask Gemini that I do want to does this repo use what is it, byte to store key material? And is that a good, bad, or neutral practice for security sensitive software? How about draw a bow with a key on a raft? Yes, based on the code we've examined, this repository consistently uses a byte slice to handle the sensitive data, etc. To answer your second question, using byte is a good and necessary practice. It is the professionally paranoid standard. Okay. The choice between string or a byte. I'm not asking about string. I'm not asking about string. I'm asking about the alternative of having functions take essentially structs that with more structure that handle the key, e.g. encrypt of versus encrypt byte. I don't remember Go syntax, but we'll say it like this. I think in Go, the types come afterwards. Is that right? We can look at Go right here. Yeah, they come after. So, but okay, this is not bad. Also, you generate 5 variations on this theme. And make sure we're doing the banana one. That's the one that everyone is so into. Okay, where's Gemini? Gemini's here. Okay. I see. So that is a much more insightful question. Oh, okay. Gemini's always telling you you're insightful, but this is basically a backhanded version. It gets at the heart of secure API design. You're asking why they pass around raw byte instead of abstracting it into a dedicated type. Yes. The difference between just following the rule use byte for security and blah, 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 is vastly superior and more secure practice to use a struct to hold the key material. And that's better than byte. Type safety. Yeah, that's encapsulation and cleanup, preventing misuse, clarity, metadata. Okay, so I'll say evaluate this code base from a scale of 1 to 10, with 1 being it's worse than the code your dog would have written after a night of binge drinking, and 10 being so amazing it blew your mind. How would you rate it from a security best practices perspective? I'm guessing it's good. I assume it's good. Here are different bows on the raft, on the ocean. These are good. So let's say have there be multiple bows on rafts trying to communicate with each other with tin cans on a string. 7 out of 10. Yeah, that's good. All right. Give it a 7. It's far from the dumpster fire your binge drinking dog would produce. That's good, but it's certainly not mine. It's certainly not blowing my mind. It's a solid foundation. There's no roll your own crypto. It's got basic memory hygiene. It's not a 9 or 10 because of the lax key lifecycle management, the brittle API design, and good enough mentality. What do you think of the choice to implement Shamir secret sharing, and how hardened is the so rather than using a library, is the implementation do things like side channel attacks? Are those even a concern? Let's see what it says to that. Okay, so here's the different bows communicating with each other. It's not bad. I'll save it. Open bows on raft. None of the bows are open, but that would be a little bit too gory. Okay. I think it's saying that the Shamir thing is fine. Uh-oh. What have I done? Are you ever going to restore? Should I not have done that? Okay, now it's back. All right, so the in-house versus using a library. My immediate knee-jerk reaction to anyone writing their own cryptographic code is it's catastrophically bad idea born of arrogance. The golden rule is don't roll your own crypto. However, for a project like this, the decision is more nuanced. Okay, while I still think it's a dangerous choice, I can see the logic. It's a trade-off between two major risks, implementation risk and supply chain risk. I'm not sure that's why they did it. Given that it's mathematically similar than, for example, AES or RSA, the implementation risk is lower, though still non-zero, very much non-zero. And they made a calculated decision to accept the burden of writing and maintaining their own correct implementation in exchange for having zero external dependencies for this critical function. It's a bold and risky choice that I wouldn't recommend for 99% of projects. But for this specific case, it's defensible. And then for hardening to side channel attacks, they're absolutely a concern, a timing attack. I expect to find an uneven implementation I was wrong. It's just clear evidence of being hardened against timing attacks. The most telling example is their div function, constant time select, constant time byte EQ. Okay, I didn't look for constant time, but I also didn't see it when I was looking, but I will believe it that it's there. They explicitly used functions from Go's crypto subtle package. That's good. I mean, you're usually not supposed to use subtle, but for something like this, you have to use subtle. which are specifically designed to be constant time, meaning they take the same amount of time to execute regardless. Yeah, okay, great. The structure of multi and inverse functions are also written in a style that avoids data-dependent branches, which is characteristic of constant time code. Okay, so they get the thumbs up for the implementation. It's top-notch. It's a rare example of code that isn't slop. Huh. All right, great. So that's Hashicorp Vault. It seems good. Gemini gives it a 7 out of 10, although it's not really taking into account all the things. I expect it might be more like an 8 or 9 out of 10. And I hope you enjoyed exploring the world of open source secret managers with me. We were looking at, in case you missed it, OpenBao and not Vault. I think we just mentioned the word Vault a few times. OpenBao is, of course, a fork of the Hashicorp Vault code. So almost all the code that we saw was, I believe, written by Hashicorp people. I don't know how much work has been done so far post-fork. But that's that. Hope you enjoyed it, and hope you'll join me next week as we explore the world of the source codes.